Hello and welcome to Mr. Linford's Math 097 course. This video is a presentation on section 2.3 of the text. In today's discussion, we're going to be exploring the topics of linear equations in two variables. In particular, we're going to be discussing the slope-intercept form of a line, the point-slope form or formula of a line, and we're going to be actually figuring out how in the world to go about writing equations of a line in two variables from different given information, and maybe we'll get into some graphing as well. Starting off with the notes for 2.3, let's go ahead and actually define what the heck slope-intercept form of a line is. Now, slope-intercept form of a line is something that most people can recall right off the top of their head. It is a formula that just describes a linear equation, and it is y equals mx plus b. This is just a formula, or a way of writing a linear equation. There are several different ways. This is the most common way because of the different components that we have within this. M stands for the slope of the line, and B is the y-intercept. So that's where it crosses the y-axis. M is the slope, and B is the number that represents where we cross the y-axis. So if we're looking at this first problem right here, we know that our slope is -3/4, and we know that our intercept, our y-intercept, is 1. So if I'm looking on the y-axis, I know that my y-intercept, and we're going to see how good my stylus is, my y-intercept is, my y-intercept is right about there. Not too bad. My y-intercept is right at 0, 1. We cross the y-axis at 1. Now my slope is going to tell me where to find that next point. The slope says to go down 1, 2, 3 values and go over 4. 1, 2, 3, 4. And right there, close enough. Let's see if I can do that again. Right about there, we'll make it work. That point, let's see, that's 1, 2, 3, 4, -2. That point, 4, -2, is our next point. So, if we're doing this on paper and we have a nice straight edge, we could connect these points and we'll say, hey, there's the graph of our linear equation. And that's a pretty standard way of going about actually graphing something. Now sometimes you might notice in our text we'll have, for a problem like number 2 here, we might have the linear equation not actually in that slope-intercept form. So it's our job to take this equation and actually solve it for y, get it in that form that we need. So if I was to do that, I might add 7x to both sides. So we have -y equals 7x minus 5. And then we might just divide both sides by -1 to get y equals -7x plus 5. So we know that our y-intercept occurs right about here. And then if we go down 7 values and over 1, because remember our slope here is 7 over 1, we can write any whole number really as over 1. So we're going to go down 7 units and go over 1, and if I counted right, we should be at right about, oh my gosh, the stylus isn't the best, right about there. And you guys know that I'm not the best at drawing straight lines, so wow, that was way off. Let's see if I can do that again. Something like this. Okay, that's terrible, but hopefully you get the idea with that. So this is how we're going to go about working with slope-intercept form. And the reason we write equations in this is because it tells us the most information. It tells us what the slope is and what that y-intercept is. So we can really quickly come up with the graph, and we'll find in the next section how we can use these actual number values to interpret the equation for different applications. Now there's another way of working with linear equations, and it's called the point-slope formula. Now the point-slope formula, the definition is y minus y1 equaling m, and in parentheses, x minus x1. I know I'm running out of space here. This is just a formula. This is a way of starting off your problem to get it into y equals mx plus b. Remember, all of our final answers should be in slope-intercept form. Every equation we write, we want it to be in y equals mx plus b. But this point-slope formula is going to help us out with that. In this formula, m is just the slope. We've seen this before. And then x1 and y1, these actually are coordinate points. This is a point on the line. This is just a point on the line. So in this next problem, let's see if we can use and kind of compare what's going on with slope-intercept form and point-slope formula. Two different techniques for going ahead and actually figuring out what the equation is. So in this problem, right here, we want to find the equation of a line that has a slope of -3, and it should go through the point 1, -4. Okay, if I'm doing slope-intercept form, and this is a common way that people are taught, I know that I want to come up with a y equals mx plus b. Well, they already tell us what the slope is. So I know that my slope is -3. So I'm actually found a big component of my equation. I know that my slope is -3. All I got to do right now is figure out what my y-intercept is. I just have to figure out what the number for b is. To do that, what we need to realize is that we're told a point on the line. Now, a point on the line, generally when I ask students, what does it mean for a point to be on the line? For a coordinate point to be a part of the graph to some linear equation, I often hear the whole, oh, well, it's just something that makes up the line, something that makes up the graph. But what we want to keep in mind is the graph of an equation, just a graph of an equation, like this graph right here. If I just graph that line, every point on this line is a solution. The graph itself is a solution set. Every point on that graph is a solution to the equation. You can take any one of these points, plug it into your equation, and I guarantee you're going to get a true statement. So knowing that, what we want to do is we're going to take that point, 1, -4, and we're going to plug it in for x and y. Okay, so I plugged in 1 for x, and I plugged in -4 for y. So we get -4 equals -3 plus b. If I add 3 to both sides, we're going to get -1 equals b. So we're assuming that our equation should be y equals -3x minus 1. So using the slope-intercept form, we were kind of told right away what the slope was, and we just plugged in the point for x and y and kind of solved for b. So that wasn't that bad. Now let's look at what we can do with the slope formula. Now the point-slope formula, we're going to plug everything in. So I'm going to say I have y minus, instead of writing y1, I know what y1 is. It's -4. And then I'm going to say instead of m, they tell me that it's -3. And then I'm going to have x minus, instead of saying x1, I know that point. It's 1. These values, 1 and -4, those are the places where I plug in the coordinate point. That's my x and my y that I plug in. So let's go ahead, and sometimes people stop here. Let's not stop here because this really doesn't tell me too much information. I want us to solve for y. So that's really y plus 4 equals, and let's distribute this -3. -3x plus 3. If I subtract 4 from both sides, I'm going to move my work over a little bit. We should get y equals -3x minus 1. What do you know? We get the exact same answer as we did before. So this is why we have two different methods for solving this, and sometimes students like one over the other. I personally like slope-intercept form, but I have a lot of students who really love point-slope formula. And honestly, either one works. It's good to know both, but really have a set method that you like to work with, okay? So for this video, I'm going to try to intermix both formulas and see which one we tend to like a little better. So let's start with some practice problems, and let's see how we can actually go about exploring the different ways of solving and coming up with equations from different given information. In this first problem, I want us to find an equation of a line that goes through the points 5, -1, and 3, 1. So we need to come up with our own y equals mx plus b. We need to find slope, and we need to find the y-intercept. Once we know those two numbers, we have our equation. So take a minute and think to yourself, how can we figure out what slope is from this problem? How can we figure out what slope is? In the previous problem, they told us what slope was. Here we don't know right away. We have to do a little bit of work. Pause the video and see if you can come up with how in the world, with this given information, all we know are 2 points on the line. See if you can figure out how we can come up with the slope. Pause the video and take some time to think about that. When we come back, we'll discuss how we got it. Okay, hopefully pause the video. Otherwise, let's go ahead and explore how the heck to find slope here. So, slope, remember, the slope can be found by the formula y2 minus y1 over x2 minus x1. This is the formula for slope. It represents how we're changing in the y values and how we're changing in x. So that's the rise over the run. So in this problem, my slope is going to be, I guess I'll call this 0.1 and this 0.2. Remember, it doesn't really matter. Oh gosh, you can't see that now. Remember, it doesn't really matter what I call 0.1 and 0.2. So if I call this 0.2, I'm going to have 1 minus -1 over 3 minus 5. 1 minus -1, that's just 1 plus 1. So what's that? 2 over... Sorry, I'm getting used to this new iPad. Let's see if I can do this a little differently. Let's move my work right up here. This is just going to be 2 over -2, which can simplify to -1. All right, we use the slope formula, and we just found what our slope is. Now, all we have to do is figure out what the y-intercept is. So I know what slope is. I know m is -1. Just got to figure out what that b is going to be. All right. To figure out what b is, we're going to do the slope-intercept form. Let's do that technique first. All I need to do is take one of these points, plug it in for x and y. I have 2 points, so I guess I'll just pick the easier one. Let's pick 3 and 1. So 1 is the y-coordinate. I'll plug it in for y. And 3 is the x-coordinate, so I'll plug that in for x. And let's see what we get. 1 equals -3 plus b. Add 3 to both sides. 4 equals b. All right, so it sounds like my equation should be y equals -1x plus 4. Notice that we started, our very first step was to figure out what the slope was. We were wanting to figure out what in the world was slope. We used that slope value to help us figure out what the y-intercept is. This is going to be true for the rest of these problems. Anytime you're writing an equation from given information, start by figuring out what your slope value is. Then use that slope value to help you figure out the y-intercept. Here we use the slope-intercept form. Maybe next time we can use the point slope formula. So let's take a look at a couple other problems. In this problem, we need to find an equation of a line passing through the point -2, -3, and is parallel to 4x plus y equals 8. Okay, this problem is going to be a little different than what we've done before. In the previous work, we had 2 points, and we knew how to come up with the slope for those 2 points. In this problem, I'm only given 1 point. And really, if you kind of picture a graph, for any given point, I could have infinitely many lines going through that. So I need some more information here. I need to know more about how I should set up my line for this problem. Now notice that they tell me that whatever line I come up with, it better be parallel to 4x plus y equals 8. Take a minute, pause the video, and see if you can think back to what it means for two lines to be parallel, and see if that helps you figure out how we can start this problem. Remember, we got to start out by finding the slope. So pause the video and see if you can use this information to kind of hypothesize how we can find slope from this. And when we come back, we'll see if we came up with the correct answer. All right, hopefully you pause the video and we're able to come up with something. If not, that's okay. When we're talking about parallel lines, a key thing to remember is parallel lines have the same slope. In this problem, I'm saying that if I have this line, 4x plus y equals 8, well, if I knew the slope of that line, then I know the slope of my line. Well, do I know the slope of this line? This is kind of some weird setup to it. This is what's called standard form. You know what? I don't want this in standard form. You know, let's go ahead and put this in y equals mx plus b. So let's go ahead and solve this for y. So I'm going to subtract 4x from both sides, so we get y equals negative 4x plus 8. Okay, so we took this linear equation, we solved it for y. It's in y equals mx plus b. This right here, negative 4, that is the slope of this line. That's the slope of this line. That's the slope of this line. Now, this equation says whatever you come up with, your slope better be the same as this slope. That's what it means to be parallel. They're kind of playing around with the vocabulary here. So if this line has a slope of negative 4, I know that my line better have a slope of negative 4 as well. So I can go ahead and plug that right in. So my equation should start off as y equals negative 4x plus b. I'm halfway there. I'm almost done. Let's use the same thing we did before. Let's just use the slope-intercept form. And let's go ahead and just plug in the point negative 2, negative 3. Negative 3 goes in for y. Negative 2 goes in for x. And let's solve for b. So let's see, negative 3 equals, that becomes a positive 8. If I subtract 8 from both sides, I should get a negative 11 equals b. I think that works. Okay. So when all's said and done, our equation should be y equals negative 4x minus 11. And what do you know? I'm actually getting used to the stylus. Cool. All right, so right here, something to take away from this. We had to have a kind of a hint here. If I just gave you the problem and said, write me an equation of a line that passes through the point negative 2, negative 3, you could write infinitely many equations. But these problems, they're written, they just want one specific equation. So they're going to have to give you some more information. So they're kind of giving you a little hint about the slope. And that's what they're going to do here. They're always going to give you a little hint to what the slope is. So they're going to tell you it's got to be parallel to a line. But let's take a look at the next problem. This one's going to be a similar idea, but a little different. Find the equation of a line passing through the point 4, 3 that is perpendicular to the line 2x plus 3y equals 3. What we need to do here is come up with our own equation, and we have to start by finding the slope. So why don't we take a minute, pause the video, and see if you can figure out what the slope of our line is going to be if we know that it has to be perpendicular to 2x plus 3y equals 3. Pause the video and take a minute for yourself to think about this. All right. Hopefully pause the video. Let's see if we can come up with the correct answer. In this situation, we're going to do the exact same thing we did before. We're going to do the exact same thing. Before, we had this idea of taking the equation they give us and figuring out what the slope is. So I'm going to subtract 2x from both sides. That becomes a negative 2x plus 3. Divide both sides by 3, I get y equals negative 2/3 x plus 1. Okay, this is what this y-intercept, or this slope-intercept form right here, that's what this equation is. This equation right here, we just rewrote it in y equals mx plus b. So the slope is right here. This is the slope of that line. Now my slope right here has to be perpendicular to this slope. I know that my equation, they tell me it's perpendicular to this line 2x plus 3y equals 3. So if this slope, if they tell me that the slope of this line is negative 2/3, my slope better be 3/2. Remember, perpendicular lines, they have slopes that are negative reciprocals. So reciprocal means flip the fraction. So if you have 2/3, make it 3/2. And then make it negative, or really just take the opposite sign. So if one slope was negative, my slope's going to be positive. If their slope is positive, mine's going to be negative. So that's what the negative reciprocal means. You flip the fraction and you flip the sign. So I know what my slope is once again. It's 3/2. I just had to do a little extra work for it. Let's actually try and use the slope-intercept form. Hopefully I got enough, or the, what's that called? The point-slope formula. So hopefully I got enough room here. Y minus y1, and I'm going to use this point. Y1 is 3. Let's see, my slope is 3/2. X minus, so my x1 is 4. So these are the spots where the spot right here and right here, this is where I just plug in that 0.43. And let's solve. Okay, y minus 3 equals 3/2x minus, I'm just distributing this 3/2. Okay, since I don't have much room, I'm just going to try and do this multiplication in my head. 3/2 times 4 is, what's that, 12/2? 12/2, it should be 6. Okay, add 3 to both sides. Y equals 3/2 x minus 3. That is not a 3. I'll get used to the stylus at some point. So right here, we have the equation that we wanted. And we did it by using the same idea as before. We're using that given information to come up with what our slope could possibly be. And then we just going through and using the point slope formula to actually come up with the equation. So we've seen a couple different examples here. We've seen some ways of going about solving these problems. These are the 3 main setups that I could use for any type of problem for you to find an equation. I could give you 2 points, like we saw in the first practice problem right here. I could give you a point in a line parallel to your line, like in the second problem. Or I could give you a point in a line perpendicular, like in the third problem. Notice that in each problem, the very first thing we do, the very first thing, is we always find slope. We find slope to start off our problem. And that's important for us. We have to know that slope first. And then we find the y-intercept. You can find the y-intercept the same way every time. We either use the slope-intercept form, like in problems 1 or 2, or we use the point-slope formula, like in problem 3. Use a method that you like. Use the one that you find that works best for you and stick with it, okay? Now, if you're interested, go ahead and try problem 4. This was just a challenge problem. See if we can prove why the point-slope formula works. It's not the most intuitive way of going about and proving why going about and seeing why something works. But see if you can kind of prove why this forms an equation. In class, I told some students, remember, you really only know for certain that ax plus by equals c. You know that this is the definition of an equation, and you know that slope is equal to y2 minus y1 over x2 minus x1. So if you're interested, try and use these 2 these two tools that you have to see if you can come up with point slope formula from these two definitions. Hopefully this was helpful to you. If not, shoot me an email. My email is always klinford, LINFORD, at wccnet.edu. And let me know what you think of the video. Until next time,